Hi, my name is Lee Bullock. As you know, together we provide service for Amtrak customers.
And I'm Doug Sizemore. We're here to talk to you about a powerful change at Amtrak that will help us meet our customers' expectations.
There are several parts of this decision we'd like you to know more about. These locomotives are more powerful, and we'll need fewer of them to handle our larger trains. The locomotives are also more fuel efficient. That lowers our operating costs. The locomotives also have extended warranties on both the P40s and the P42s, and that will lead to increased reliability and improve on-time performance and increase customer satisfaction, and that's crucial to our survival.
Amtrak faced a decision. We could buy for the future or build with old technology. We could remanufacture the F40 locomotives, spending millions of dollars, and extend the life approximately 10 years. At that time, we would have a fleet that would be 30 years old, it would lack the efficiencies of modern units, and it would not incorporate all of the safety features.
Better braking control and a more powerful prime mover will assist with proper handling of the train. These locomotives also have some of the most sophisticated technology available today.
So a decision was made to add to the General Electric fleet and place an order with GE to purchase 98 new P42 locomotives. This would be in addition to the Genesis fleet that was purchased in 1993. These locomotives will carry us into the 21st century.
These locomotives represent a huge investment in passenger rail service in the United States. They also reflect Amtrak's commitment to long-distance trains. They will improve our safety, they will lower our operating costs, and they will improve customer satisfaction through increased reliability.
And while these P42s at first glance might look like the P40s, we have been talking to and listening to the engine train crews. While every idea could not be incorporated, many were. We now would like to talk about those improvements that are on the P42s and will be put on the P40s when they are shopped in the future. Some of those improvements start on the outside of the locomotive. You will notice a change in the steps. On the inside of the locomotive, we have improved cab lighting around the desk and on the floor. For the computer, there's been a visor added, so the computer screen will be more visible with different lighting conditions. The computer has upgraded software that makes it more easy to interpret and user-friendly. The air conditioning and heating is thermostatically controlled, and the vents are adjustable. The seats have more adjustments. This locomotive incorporates many of your suggestions, and it will be upgraded on the P40s when they are shopped in the future.
As many of you know, the F40 has been the face of Amtrak for a long time. It's the image people often think of when they think of our trains and our locomotives. That's not surprising because these locomotives have been with us for a long time. Unfortunately, these locomotives in many ways are worn out.
And that's why we have made this video training series with GE Transportation Systems. We want you to know how the P42 works, why it works, how it works, to improve your knowledge of the P42 so you can make a safe, on-time trip every time you make a run. So Lee and I thank you for giving us a few moments to introduce this video series. This is an essential part of Amtrak's investment into the future. An investment into locomotives, and an investment in the most important asset the company has in you, our people.
The Amtrak P42 represents the latest technological advances in passenger locomotives. After viewing this program, the Amtrak P42 overview, you will be able to explain the P42's operating characteristics, identify the location and function of its operating controls, identify and locate the electrical control equipment, and identify the unit's major components and their role in the operation of the locomotive. Also, we'll be discussing the precautions that must be followed to operate the locomotive safely. We've divided this program into the 5 areas of the locomotive. They are the operator's cab, the auxiliary compartment, the engine compartment, the radiator compartment, and the exterior. We'll begin in the operator's cab. There is the engineer's control console, the center console, the assistant engineer's console, operator cab ceiling devices, operator cab equipment, and located behind the engineer, the engine control EC panel and Control Area 1. Let's take a closer look at each of these areas. The engineer's control console is fitted with the control devices that are used to operate the locomotive. The air brake controller is on the right side of the console. The automatic brake handle combines the function of controlling both the automatic brake and the dynamic brake when using blended braking. The system is designed to supply as much dynamic braking as possible, with the remainder of the required braking coming from the standard air brakes. Blended braking is prevented when the combined power handle is in a position other than idle, and when the brakes have been bailed off. The automatic brake handle operates through 6 detented control positions. They are release, minimum reduction, suppression, full service, handle off, and emergency. The service zone is between the minimum reduction and the full service positions. Release is selected when charging a train or releasing an automatic brake application. The handle position is closest to the engineer. The minimum reduction position provides a 5 to 7 pound reduction of the brake pipe pressure. Moving the automatic brake handle away from the engineer into the service zone increases the reduction. Suppression provides a 15 to 19 pound reduction. Moving the handle farther to the third raised position causes a full service reduction of 23 to 26 psi. The handle off position is for trail unit operation, push service operation, and when the unit is dead in tow. Moving the handle to emergency, the farthest position from the engineer initiates an emergency brake application. The independent brake handle controls the application of the brakes on the locomotive only. To apply the independent brake, move the handle away from the engineer. To release the independent brake, move the handle toward the engineer. The independent brake should always be in the release position when the unit is in trail operation, when it is dead in tow, or when it is operating in push service. To make an independent release of an automatic brake application, pull up on the ring on the independent brake handle. You must hold the ring up for 4 seconds per locomotive in the consist to allow proper actuation to fully bail off the brakes on all the units. The brake pipe cutoff pilot switch is located below the independent brake handle. It performs the function of the brake pipe cutoff pilot valve. The switch has 4 positions. They are trail for operating in trail position in a multiple unit consist, in push service, or dead in tow. Test is selected when performing a brake pipe leakage test. The pressure maintaining feature is nullified when the switch is in test. Turning the switch to the freight or passenger positions restores control of the automatic brake. The freight and passenger positions are for instances when the unit is in the lead position. While the freight position provides a direct release of the brakes, passenger provides a graduated release of the brakes. The onboard computers may limit loading if the automatic brake is applied while the locomotive is operating in power mode. You must follow Amtrak's operating rules when using the brake system. Let's examine the power braking restriction and the logic behind it. The control system imposes restrictions to prohibit the excessive use of air brakes during motoring. Automatic limits are enforced by the control system in two different ways, depending on the position of the brake pipe cutoff pilot switch. The passenger operation restriction occurs when the switch is in the passenger position and there is a minimum automatic brake application or an automatic brake application beyond minimum brake for more than 30 seconds, when the combined power handle is in notch 5 or higher and the locomotive speed is 12 miles per hour or greater. If the unit is above notch 4 when the limits are imposed, throttle call is reduced by 1 notch every 4 seconds until notch 4 is reached. Load-limited too much power braking appears in the summary message area on the IFD screen. This condition resets after the engineer moves the combined power handle to notch 4 or lower, and there is no brake application for 2 seconds. The freight operation restriction occurs when the brake pipe cutoff pilot switch is in the freight position, and there is a minimum reduction for more than 3 minutes, when the combined power handle is in notch 5 or higher, and the locomotive speed is 12 miles per hour or greater. If the unit is above notch 4 when the limits are imposed, throttle call is reduced by 1 notch every 4 seconds until notch 4 is reached. Movement beyond minimum reduction automatically reverts to passenger power brake logic. Load-limited too much power braking appears in the summary message area on the IFD screen. This condition resets after the engineer moves the combined power handle to notch 4 or lower, and there is no brake application for 2 seconds. You should be aware that a traction motor stall condition can occur when the combined power handle is in notch 1 or higher and the traction motor speed is 0 miles per hour. If the brakes are applied for more than 10 seconds with the combined power handle in notch 1 or higher and the traction motor speed is 0 miles per hour, the computer restricts the alternator current. An alarm sounds for 5 seconds. The summary message area on the IFD screen displays, "Please move throttle to idle." The traction motor stall condition resets after the operator moves the combined power handle to idle for 2 seconds. The master controller is to the left of the air brake controller. The combined power handle controls locomotive load and dynamic braking effort. Moving the handle from idle toward the engineer gives you motoring from notch 1 through notch 8. Moving the handle away from the engineer through a gate takes the unit from setup, which connects the traction motors in series and connects their armatures to the grid resistors, into dynamic braking from DB1 through DB8. The position of the reverser handle determines the direction of locomotive travel. The selections are forward, centered or neutral, also called off, and reverse. The reverser may be removed in the neutral position. Remove it when the unit is going to be unattended, or if it is operating as a trail locomotive, in push service, or if it is dead in tow. When the reverser is removed, an interlock prevents the combined power handle from moving. Pressing the horn button, located on the engineer's control console only halfway, sounds the horn at 1/2 of its full volume. A full press allows the horn to sound at full volume. The horn and the crossing bell are interlocked, and both sound when the horn button is pressed. Additionally, pressing the horn button causes the crossing lights to come on and begin alternately flashing. The horn stops when the horn button is released. The bell continues to sound until the bell button is pressed, and the crossing lights continue to flash for 30 seconds. The lead axle sanding switch applies sand to the rail in front of the leading axle of the leading truck on the lead locomotive. The sand is applied at any speed. The sanding switch applies sand in front of the lead axle of each truck in the consist when the train is moving less than 7 miles per hour. Above 7 miles per hour, the sanding switch is disabled, and sanding is controlled by the onboard computers. The acknowledge push button and the alerter whisker switch both reset the alerter timer. To prevent a penalty brake application, any one of the following must occur within a set time interval. Either switch must be activated. The combined power handle or reverser must be moved. The automatic brake handle must be moved into or out of release. The bail-off feature must be activated, or the horn or bell must sound. The acknowledge push button is also used to indicate that the engineer has recognized a downward change in cab signal status. Failure to respond to the cab signal status change also causes a penalty brake application. A clipboard is provided to help the engineer organize paperwork. 2 of the 3 integrated function display IFD screens on the Amtrak P42 are located on the engineer's control console. The IFDs are the primary method with which the engineer receives the information required to operate the train safely and efficiently. The locomotive's speed is displayed in both digital and graphical formats. An acceleration pointer or predictor calculates what the speed will be in 1 minute if operating conditions remain unchanged. The load meter indicates motoring and braking amperage in both digital and graphical formats. The air brake information zone contains air brake equipment operating pressure. Both the brake pipe pressure and the equalizing reservoir pressure are displayed in digital and graphical formats. The regulating valve setting is indicated by graphical triangles. Brake cylinder pressure, reduction pressure, last car pressure, and the main reservoir are displayed in a digital format. Operation warning lights illuminate if conditions outside the normal operating range occur. Fault messages are displayed identifying the problem area and explaining the trouble in more detail. Most operating functions are set up and controlled from the IFDs. These include cruise control, the electronic air brake regulating valve setup, and the end of train setup. System tests can be performed from the IFDs and status information is available. These tests include the cab signal test, the air brake departure test, the alerter magnet valve test, and the speed check. The update information includes the fuel monitor status and the distance counter. Pressing the full screen brightness push button next to the right engineer's screen restores all IFD screens to maximum brightness. The MU emergency shutdown push button switch shuts down all of the MU'd locomotives in the consist. The button must be set to the run position to restart the unit. The spotter push button is pressed to move a locomotive using only battery power, such as in a shop area. The diesel engine may or may not be running. The cab signal overspeed display panel has a warning light, a SON alert, and a selector switch. The front and rear headlight switches have 4 positions: off, dim, medium, and bright. If the train is equipped with a 2-way end-of-train device at the rear of the train, throwing the EOT rear emergency brake switch vents the brake pipe from the rear of the train at an emergency rate. The crossing light selector switch turns on the crossing lights in a non-flashing mode. The parking brake applied indicator informs the engineer of the parking brake status. The parking brake must be released before normal operation. The slow speed devices control the slow speed backing operations. These include the enabled indicator, the backing push button, and the backing excitation controller. Refer to the operator's manual for additional information on the operation of slow speed backing. The lower console contains additional operating circuit breakers. The engine run breaker must be on to control diesel engine speed. The generator field breaker permits control of the generator output. The control breaker provides power to train line control positive. The dynamic brake circuit breaker allows control of the dynamic braking output through the combined power handle. These breakers should be on for lead operation and off for trail operation. In push service, only the control breaker is on. The gauge light toggle switch is at the end of the row of circuit breakers. The window heater, the power limit switch, and the step light switches are located below. The power limit switch limits power to notch 7 on the lead locomotive. This function is not train-lined. The heater air conditioner control switch selects between various heater and air conditioner settings. The air conditioner control knob allows the engineer to set the temperature of the air coming from the heater and the air conditioner. The train line ground reset push button silences the electronic air brake alarm. This receptacle provides 74 volts DC. The gauge lights may be adjusted to compensate for lighting conditions in the cab. The floor-mounted horn sequencer switch integrated to the onboard computer system is operational when the locomotive is traveling above 1/2 mile per hour. One press starts the horn sequence that also activates the bell and crossing lights. The horn sounds 2 long, 1 short, and 1 long blast. The bell rings and the crossing lights alternately flash. Pressing the horn sequence foot switch again silences the horn. You must press the bell button to stop the bell. The crossing lights continue to flash for 30 seconds. The floor-mounted radio foot switch permits the engineer to use the radio when wearing a headset. The center console contains the HEP control panel, the radio, and handset. There is an emergency brake valve push button on the left side of the console. Pushing the button initiates an emergency brake application. To reset, you must pull out the button. Beneath the radio are the cab floor lighting switch that controls the lights that are located where the floor height changes, and the cab dome light switch. The cab signal aspect display is above this console. This unit displays the cab signal aspect as received electronically from the track. There is a switch on the top of the display that must be set according to the cab signal territory in which you are operating. The Qualcomm Train Communication Controller sends and receives data. Caution: the engineer must never access this device while operating the locomotive. The entrance to the nose compartment is located below the center console. The operating air to the front sand magnet valves may be cut out using the cutout cock located in the nose compartment. The assistant engineer's console is fitted with the unit's third integrated function display. Although it is used to monitor locomotive performance, such as measured mile, fuel monitor, the distance counter, and perform diagnostic tests, other operator functions are disabled. A horn button is to the left of the IFD screen. Below the horn button is the assistant engineer's headset station. A clipboard is built into the desktop. A radio handset for the assistant engineer is to the left of the console. A 110-volt AC receptacle is at the bottom of the left side of the console. Let's start back at the engineer's control console and look at some of the operator's cab ceiling devices. A visor is provided to reduce the nighttime glare from the IFD screens in the side mirror. Above the engineer's area are the engineer's light controls, the engineer's desk light and switch, and the engineer's reading light and switch. The audio-visual alarm AVB box is located above the center control console. This device provides audible tones and flashing lights when the alerter, locomotive overspeed, or end-of-train device requires the engineer's attention. The area above the assistant engineer's console is fitted with desk and reading lights and devices similar to those above the engineer's control console. An auxiliary headset station and dome light are located in the center area of the cab ceiling. Operator cab equipment is located conveniently within easy reach of the crew members. The engineer's headset station is located near the bottom right wall of the operator cab. A first aid kit along the wall and 2 fire extinguishers, one behind the engineer's seat and one behind the helper's seat. Windshield wiper controls are mounted along the engineer's and assistant engineer's side walls. A push button activates the windshield washer. The parking brake controller applies and releases the parking brake. If there is no main reservoir pressure, the parking brake may be manually released after the wheels are chocked. The dead engine feature also can be cut in to release the parking brake if the brake pipe pressure is above 90 psi. The parking brake must be released before operating the locomotive. The auxiliary cab heater provides additional heating when required, such as during cold morning startups. The refrigerator, powered by 110 volts AC, functions when the head-end power is operating. There are 3 air conditioner heater vents in the operator's cab. In addition to a vent next to both the engineer and the assistant engineer, there is a vent above the EC panel behind the engineer's cab seat. The windows are tinted, and sunshades are provided to reduce glare to improve visibility and increase crew comfort. Mirrors help monitor train conditions. A fresh air damper allows the fresh air supply to the cab to be shut off in extreme weather. The dead engine cutout cock, the bell cutout cock, and the control air cutout cock are located beneath the operator's cab floor. Now let's turn our attention to the rear of the operator's cab and the EC panel. The EC panel contains the circuit breakers, switches, and other devices that must be set for proper locomotive operation. The top row of the EC panel contains circuit breakers. Turn on or off the required breakers for lead or trail operation. The top row breakers consist of the window heater circuit breaker, the cab signal circuit breaker, the satellite system circuit breaker, the road crossing light circuit breaker, the 74-volt DC radio circuit breaker, the 12-volt radio circuit breaker, and the front and rear headlight circuit breakers. The first device on the EC panel's second row is an engine stop push button, which shuts down the diesel engine on this unit only. The circuit breakers on this row must be on when the locomotive is operating in both lead and trail positions. They control the air brake computer, the 120-volt AC radio battery charger, the 120-volt AC receptacle, the air dryer circuit, the running lights, which includes all of the lights except the headlights and crossing lights, the marker lights, the fuel pump, local control, and the battery charge and computer. The engine control EC switch has 4 positions. Start completes the circuit in the starting system that enables the diesel engine to crank when the fuel prime engine start switch is turned to the start position. Isolate holds engine speed to idle. In this position, power cannot be applied to the propulsion system, and the unit is considered off the line. Run should be selected when the engine is idling and the locomotive is going to be operated. Jog completes the circuit that enables the unit to be moved under battery power with or without the diesel engine running. The spotter push-button feature will not operate unless the EC switch is in the jog position. The MU headlight switch should be set according to the locomotive's position in the consist and its direction of travel. 5 additional switches control lighting on the unit. They are the control compartment light switch that provides light in control areas 1 through 5, the front and rear marker light switches, the front number light switch, and the engine room maintenance light. This light will only come on when head-end power or shop power is available. The traction motor cutout switches may be used to cut out 1 or more traction motors. Caution: always have the engine control switch in isolate and the combined power handle in idle before cutting out a motor. Always follow all Amtrak safety rules and regulations regarding traction motor cutout. Cutting out a traction motor affects the performance of the unit on which the motor is cut out. Power output may be reduced, and dynamic braking will not be available. The speed sensor cutout switch cuts out the speed sensor on any traction motor that is cut out. To ensure that wheel slip protection is retained, the speed sensor is only cut out if a traction motor cutout switch has been thrown. Use the switch only to eliminate a faulty sensor. First, you must determine that the wheel involved is not locked or sliding. The locked axle alarm cutout switch cuts out the locked axle alarm. Before using this switch to silence the alarm, determine that the wheels are rolling. The alerter, cab signal system, and overspeed may be cut out if the associated equipment is not functioning properly. However, you must follow all Amtrak regulations governing the use of these switches. The cab signal transfer switch selects between the cab signal system and the intermittent inductive train stop system. The Battery Connect push button is another device on the lower section of the EC panel. Since the P42 battery saver circuit disconnects the batteries 15 minutes after the diesel engine is shut down, use this push button to reconnect the batteries before you start the unit. Critical circuits continue to be powered even when the battery save circuit is engaged. The battery charging ammeter indicates current flowing into the batteries when they are charging and out of the batteries when they are discharging. The no battery charge light comes on when the battery charge circuit is inactive. Control Area 1, CA1, is next to the EC panel at the back of the operator's cab. It houses the computers that monitor the locomotive's operating systems and most of the locomotive's low-voltage operating equipment. The left side of CA1 contains control relays. Control circuits such as the MU shutdown system and control devices make up the rest of the left wall. They include the Intermittent Inductive Train Stop Controller, IITS, with its reset button. Current from the battery to all but the most critical circuits that must remain online flows through the battery switch. To start the locomotive, the battery switch must be closed. The middle area of Control Area 1 contains the control switch panel. Among the switches is the Auxiliary Alternator Field Cutout Switch, BFCO. This switch enables and disables the alternator field contactor. The fan reverse switch, a momentary contact switch, sends a fan reverse request. The backward rotation of the fan blades blows debris from the radiator fan inlet screens. The request is granted only if the reverser handle is centered. The onboard computers also share this area. They are the IFC, the cab, the X, the aux, and the HEP. The IFC processes the information it receives from various locomotive systems, such as the air brake system, and sends it to be shown on the Integrated Function Displays, IFDs. The permanent core memory records locomotive event data. This information is downloaded onto recorder hard cards through the custom record device CRD slot. The cab controller is the master processor. Its outputs are based on requests from the engineer, other onboard controllers, and the train line. X receives information from the cab controller. It also controls diesel engine loading while it monitors onboard generators and motors. The aux controller receives inputs from HEP, X, and onboard sensors for use in controlling auxiliary systems. The HEP controller controls the head-end alternator output and blended braking. The end-of-train monitor receives air brake pressure and data from the rear-mounted end-of-train device and sends the information to the IFC. The right wall of Control Area 1 contains additional circuit breakers, control devices, and control relays. The circuit breakers in this area include the 480B breaker, provides power to the locomotive's 120-volt AC outlets. Overcurrent protection for the devices is provided by their respective circuit breakers, the head-end power generator, the air conditioner heater unit, and the redundant battery charging panel. The hot bearing protection panel receives temperature signals from the traction motor support bearing temperature sensors on this locomotive only. Status reports are sent to the X controller. If a hot bearing is detected, a continuous alarm sounds and warnings appear on the hot bearing detection panel and the IFD when the unit is traveling above 10 miles per hour. Push alarm reset to silence the alarm. The alarm automatically stops sounding when the speed is reduced to below 10 miles per hour for 30 seconds. Follow Amtrak's rules and regulations regarding hot traction motor support bearings. That completes our look inside Control Area 1 and our tour of the operator's cab. The toilet compartment is conveniently located just behind the operator's compartment cab door on the way to the next area we will discuss, the auxiliary compartment. This area is an electrical compartment divided into 4 control areas. Warning: high voltage is present in this section of the auxiliary compartment when the locomotive is under load, when head-end power is provided, when battery charging is taking place, and when the radiator fan or equipment blowers are operating. The door interlock switch, DIS, is used for safety protection from high voltage in the auxiliary compartment. The door interlock switch opens with the door, dropping out the control contactors. The head-end power alternator, auxiliary alternator, and traction alternator unload. All high-voltage electrical power above 74 volts is removed. When entering this compartment, you should follow these additional safety precautions. Open the auxiliary alternator cutout switch BFCO on the control switch panel in CA1 before entering the compartment, and make certain that HEP is shut down on all of the units in the consist, as well as from a wayside source. Control Area 2 is on the right-hand wall past the rear of the toilet compartment. This panel contains cranking components, the computer power supply, and a variety of modules and relays. Control Area 3, directly across from the electrical compartment door, contains many of the high voltage and high current devices. The propulsion contactors include the power contactors P1 through P4 that connect the traction motor circuits, and the braking contactor that configures the traction motor fields for dynamic braking. The brake motor isolation switch, BS, connects the traction motors to the braking grids during dynamic braking and self-load. It also isolates the grids during motoring. The HEP lead isolate switch, LIS, removes power from the front-end HEP receptacles. The HEP transfer switch, HETS, connects either the head-end alternator or the traction alternator as a source of head-end power. The reverser, REV, changes the direction in which the traction motors turn, allowing the locomotive to change direction. Control Area 4 is on the left-hand wall as you enter the compartment. It contains the regulating panels. These panels take in 3-phase AC power and convert it to DC for use in the control systems. These panels are interchangeable. The alternator blower thermal overload device, ABOL, monitors the blower current and opens the circuit in the event of an overcurrent condition. The ABOL is equipped with a reset. The equipment blower panel, EBP, and the radiator fan panel, RFP, send out altered three-phase current to control motor speed. The two panels are interchangeable. Control Area 5 is on the right-hand wall as you enter the compartment. Now let's move on to the engine compartment. On our way, we want to point out the cutout cock for the horn. It's located down and to the right as you enter the engine compartment. Let's start with the power generation equipment. Power is generated by the alternator that consists of 3 alternator compartments: the traction alternator, the auxiliary alternator, and the head-end power alternator that are driven by the same shaft. The three-phase alternating current from the traction alternator is sent directly to the power rectifiers, where it is converted into direct current for the traction motors. The three-phase alternating current from the auxiliary alternator operates blowers and fans, and provides battery charging and excitation. The three-phase alternating current from the head-end power alternator supplies power to the train. The engine start station is on the engineer's side of the locomotive next to the traction alternator. It contains the following pressure gauges: fuel oil, turbo air, and lube oil. A 3-position fuel prime engine start switch and an engine stop switch are on the same panel. Before starting the diesel engine, check all fluid levels and follow all railroad operating and safety procedures. After making certain that the battery switch is closed, that the MU push button is in run, that the BCPB has been pressed, that the EC switch is in the start position, and that all of the proper breakers are on in the operator's cab, the engine may be started. Move the fuel prime engine start switch to the prime position. Observe the fuel flow sight glass to make sure it is free of bubbles. The fuel pressure should rise to about 55 psi. After the pressure stabilizes, move the switch to the start position. After a 3 to 5 second pause, the engine begins to rotate. Hold the switch in the start position until the engine is running. With electronic fuel injection, there is no lay shaft. The fuel is metered automatically by computers in the EFI control system. Should you need to shut down the diesel engine, press the engine stop push button. The 7FDL diesel engine can produce up to 4,250 horsepower. Let's look at some of its many components. A single turbocharger mounted on top of the diesel engine is driven by the engine exhaust gases. It provides compressed air to the cylinders. 2 intercoolers lower the temperature of the intake air as it flows from the turbocharger. The computer-controlled electronic fuel injection has eliminated the need for a rack, its associated linkage, a governor, and a lay shaft. Proper engine operation requires a reliable lubricating oil system. The diesel engine oil level can be checked with a dipstick located on either side of the diesel engine. Next to the dipstick is the oil fill, used for adding oil. The engine must be idling for proper oil level readings. Oil pressure is monitored by the lube oil pressure sensor and diesel speed is controlled to prevent damage. The pressure inside the crankcase is monitored by the crankcase overpressure sensor, COP. If the sensor detects an overpressure condition, a signal is sent and the diesel engine goes to idle. The cooling water system has a 210-gallon capacity water tank. Tank level can be determined by the water level sight glass. The tank can be filled through the radiator fill fitting when the radiator fill valve is in the open position. You must relieve pressure in the cooling system before adding water by opening the pressure relief valve. Caution: if the pressure cap must be opened, shut down the engine and relieve any pressure through the pressure relief valve. The cooling system is monitored by the engine water temperature sensor, EWT. It sends water temperature data to the aux controller, where it's used to determine radiator fan speed control and other functions. A drain valve in the sump allows for system draining. The combustion air system delivers cool, clean air to the power assemblies for combustion. The filtration system consists of V-screens, spin filters, and baggy filters. Summer-winter doors are manually operated to provide air from the engine compartment when air intakes are blocked with ice or snow. Caution: summer-winter doors must remain closed when the outside temperature is above freezing. An engine air filter pressure switch, EFPS, monitors the condition of the baggy filters. It sends a signal to the cab controller. The pressure and temperature of the intake air is monitored by the manifold air temperature sensor and the manifold air pressure sensor. The fuel oil system delivers diesel fuel to each power assembly. Under normal operation, fuel is drawn from the tank through a preheater and its automatic temperature valve by the fuel transfer pump. It is sent through the fuel filter. From the filter, the fuel goes to the supply lines to the high-pressure pump on each cylinder. Fuel flow control valves are located on either side of the engine cab. A fire extinguisher is also located in the engine cab. Those are the engine compartment components. Now let's look at the radiator compartment and its subsystems. We'll begin with the electrical equipment cooling system. This equipment blower assembly provides cooling air to the traction motors in the rear truck. The filtered air is forced into the traction motors. Dirty air from the filters is exhausted into the radiator cab by the exhauster blower attached to the equipment blower. The air compressor is AC motor driven. It is designed to provide near optimum train charging with the diesel engine running at idle. The air compressor must be off before checking or adding lubricating oil. The local control circuit breaker located on the second row of breakers on the EC panel must be turned off before performing either procedure. The oil dipstick is used to determine lubricant level. Oil may be added through the fill cap. The cooling system maintains a nearly constant engine operating temperature with a pressurized wet radiator system. 2 radiator sections are used, and they each have their own shutters. The radiators are cooled by a single fan that is controlled by the radiator fan panel. The rear sander cutout cock is inside the radiator compartment beneath the sandboxes. Control Area 9 houses the air compressor drive contactors and the traction motor blower sensor. The entrance to Control Area 9 is protected by a door interlock switch that opens with the door, dropping out the control contactors. The air compressor control panel is next to Control Area 9. The panel houses the air compressor control devices and the shutter control valves. The compressor governor switch, CGS, provides an input signal to the X controller for the operation of the air compressor. The compressor magnet valve is used to load the air compressor during pumping operation. The compressor cutout cock is used for maintenance. Extra equipment found in the radiator compartment includes a basic toolbox, and as an additional safety feature, a fire extinguisher. The short hood or front end of the Amtrak P42 is fitted with the latest, most advanced locomotive lights available to improve your visibility and help you to be seen by others along the right-of-way. There are twin front headlights, crossing lights, marker lights, and number lights. The electrical connections are color-coded for easy identification. The locomotive control MU connection has a black jumper and a black receptacle. It is the railroad standard trainline multiple unit 27-pin jumper. The communications MU connection has a blue jumper and receptacle. This line is used for communication between the locomotive and the passenger cars. The head-end power connections for the left and right side have red jumpers and receptacles. These carry the 480-volt 60-cycle AC power to the passenger cars. The air MU connections are also standard railroad connections. They are the brake pipe, main reservoir supply, main reservoir equalizing, actuating, independent application and release. Sand fill boxes are located on both sides of the locomotive, behind flush mount body doors. Sand traps are at the bottom of each sand box. The couplers are AAR Type F and are configured for uncoupling from either side of the locomotive. The uncoupling mechanism is located behind the snowplow. The cab signal inductive coils are mounted behind the front pilot plate. They receive cab signal information. The air brake compartment is located on the right side exterior. The air brake compartment houses the Knorr electronic air brake equipment. It is designed to provide the latest electro-pneumatic control over the air brake system while maintaining the same functionality of conventional 26L equipment. The New York Air Brake Knorr pneumatic control unit provides the air portion of the electronic air brakes. It is important to have clean, filtered air to help cool the locomotive equipment that is sensitive to excess heat. The right side of the Amtrak P42 is fitted with air intake screens. The dynamic brake air intake screens are mounted directly behind the right side front entrance door. The equipment blower air intake, the combustion air intake, and the radiator air intakes are filtered through V-type screens. The 2,200-gallon fuel tank has a fill rate of 300 gallons per minute. The fuel tank on each side of the locomotive is divided into two compartments, front and rear, for a total of 4 separate compartments. Each compartment has a supply and return shutoff valve. These valves must be open during normal operation. If one of the fuel compartments is leaking, Ensure that the other compartments have room to accept the fuel from the leaking compartment. Close the return valve to the leaking compartment. Close the supply valves on the other compartments and run the fuel pump until the leaking compartment is empty. When the leaking compartment is empty, close the supply valve for that compartment and open the supply valves to the other compartments. 3 digital fuel gauges are provided, one on each side of the locomotive and one in the radiator cab. The fuel level also appears on the integrated function display. The level displayed is approximated by adding the amount of fuel in the right front and the left rear fuel compartments and multiplying it by 2. 4 circular fuel level sight glasses are provided for each of the 4 fuel compartments. Remember, emergency fuel cutoff switches are provided on each side by the fuel fills at the diesel engine start station and on the EC panel in the operator's cab. The Amtrak P42's trucks and suspension system were designed specifically for the new Amtrak fleet of locomotives. The locomotive frame rests on 4 secondary springs located on each truck. The truck frame rides on primary springs that are seated over each journal-bearing housing. The bearing at each end of each axle transmits the weight of the locomotive to the rail. Axle snubbers help reduce spring oscillations. Horizontal, lateral, and vertical snubbers are provided for improved ride control. Tie rods connect the bearing housings and provide force transfer equalization. A unitized Knorr parking brake unit is provided that incorporates a spring-applied, air-released parking brake. A special tool is provided to enable you to operate the manual parking brake release handle by hand. The sand brackets and pipes are attached to the truck frames. Let's look at the air brake system components on the right side exterior of the Amtrak P42. The number 2, or right side main reservoir, is located directly behind the number 2 main reservoir final filter and the auxiliary air final filter. The brake cylinder cutout cocks and the parking brake cutout cocks are located on the right side of the locomotive. One of each can be found near both trucks. All cutout cocks are labeled on the car body. One of the battery boxes is located behind the fuel tank. The other is located on the other side of the locomotive. The toilet drain is mounted behind the lead truck. 3 locomotive entrance doors are located on each side of the locomotive. One leads to the operator's cab. Another takes you to the radiator compartment. The 3rd access door used for engine servicing is at the engine compartment. When entering any door, you must remember to place your foot firmly on each step, including the top step, to avoid injury. Caution: do not ride on the operator cab steps while the locomotive is moving. The horn is mounted on the roof above the alternator. There are 3 antennas, one for the Qualcomm system, one for the voice radio, and one for the end-of-train device. The exterior lights and markings on the number 2 or rear end of the locomotive consist of the rear headlights, the marker lights, and the decal. The number 2 end has the same electrical multiple unit connections as the front or number 1 end. The locomotive control MU connection has a black jumper and black receptacle. The communications MU connection has a blue jumper and receptacle. The head-end power connections for the left and right side have red jumpers and receptacles. The air MU connections are also standard railroad connections. An entrance door located at the rear of the locomotive allows passage between units. The fill ports for the two rear sandboxes are on both sides of the rear entrance door. Much of the left side exterior of the Amtrak P42 is identical to the right side. Here we find the number 1 or left side main reservoir. The twin tower air dryer used to condition the air is located in line between the number 1 and number 2 main reservoirs. Cutout cocks are located on each side of the twin tower. There are a couple of areas that are unique to the left side of the locomotive. Caution should be used around the dynamic brake exhaust vent. Hot air is present during operation such as self-load and dynamic braking. The last component we come to in our overview is the heater air conditioner unit. It is mounted under the cab floor on the left side of the locomotive. Well, that completes our overview of the new Amtrak P42 locomotive. We hope that you've enjoyed discovering what's new about this powerful addition to Amtrak's fleet. With the continued support of both the operating department and the mechanical forces in maintaining Amtrak's high standards of operations and maintenance, the new P42s will provide many years and millions of miles of service. At each end of each axle transmits the weight of the locomotive to the rail. Axle snubbers help reduce spring oscillations. Horizontal, lateral, and vertical snubbers are provided for improved ride control. Tie rods connect the bearing housings and provide force transfer equalization. A unitized Knorr parking brake unit is provided that incorporates a spring-applied, air-released parking brake. A special tool is provided to enable you to operate the manual parking brake release handle by hand. The sand brackets and pipes are attached to the truck frames. Let's look at the air brake system components on the right side exterior of the Amtrak P42. The number 2, or right side main reservoir, is located directly behind the number 2 main reservoir final filter and the auxiliary air final filter. The brake cylinder cutout cocks and the parking brake cutout cocks are located on the right side of the locomotive. One of each can be found near both trucks. All cutout cocks are labeled on the car body. One of the battery boxes is located behind the fuel tank. The other is located on the other side of the locomotive. The toilet drain is mounted behind the lead truck. 3 locomotive entrance doors are located on each side of the locomotive. One leads to the operator's cab. Another takes you to the radiator compartment. The third access door used for engine servicing is at the engine compartment. When entering any door, you must remember to place your foot firmly on each step, including the top step, to avoid injury. Caution: do not ride on the operator cab steps while the locomotive is moving. The horn is mounted on the roof above the alternator. There are 3 antennas, one for the Qualcomm system, one for the voice radio, and one for the end-of-train device. The exterior lights and markings on the number 2 or rear end of the locomotive consist of the rear headlights, the marker lights, and the decal. The number 2 end has the same electrical multiple unit connections as the front or number 1 end. The locomotive control MU connection has a black jumper and black receptacle. The communications MU connection has a blue jumper and receptacle. The head-end power connections for the left and right side have red jumpers and receptacles. The air MU connections are also standard railroad connections. An entrance door located at the rear of the locomotive allows passage between units. The fill ports for the two rear sandboxes are on both sides of the rear entrance door. Much of the left side exterior of the Amtrak P42 is identical to the right side. Here we find the number 1 or left side main reservoir. The twin tower air dryer used to condition the air is located in line between the number 1 and number 2 main reservoirs. Cutout cocks are located on each side of the twin tower. There are a couple of areas that are unique to the left side of the locomotive. Caution should be used around the dynamic brake exhaust vent. Hot air is present during operation such as self-load and dynamic braking. The last component we come to on our overview is the heater air conditioner unit. It is mounted under the cab floor on the left side of the locomotive. Well, that completes our overview of the new Amtrak P42 locomotive. We hope that you've enjoyed discovering what's new about this powerful addition to Amtrak's fleet. With the continued support of both the operating department and the mechanical forces in maintaining Amtrak's high standards of operations and maintenance, the new P42s will provide many years and millions of miles of service. The future of railroad motive power. The Amtrak Genesis Series 1. Built by GE, the Genesis Series 1 represents the latest generation of modern passenger locomotives. We'll be taking a look at some features found only on the Genesis Series 1 and some of the features it has in common with other GE locomotives. The Genesis Series 1's smooth lines are due in part to its monocoque construction. On the outside, the new streamlined body reduces wind resistance and improves fuel economy. The new lightweight unibody monocoque design is so strong that underneath the shell, the heavy twin I-beam sill used on freight locomotives has been eliminated. The monocoque's computer-controlled 7FDL engine delivers 4,000 horsepower. With the head-end power turned on, the computer regulates the engine speed at 900 RPM. Precision computer control of head-end power, frequency, power, and voltage is crucial to passenger comfort and equipment reliability. Let's go inside the cab and see the exciting changes. The latest sound-absorbing insulation reduces road noise. All the controls are easily reached by the operator. The Integrated Function Display, or IFD, allows the operator to communicate with the onboard computers that monitor operator commands and locomotive systems. The view-only screen on the helper's console displays information, but does not accept commands. You may refer to a separate GE video training program for more information on Integrated Function Control, or IFC, operation. The MU Stop Push button is to the right of the display screen. This must be in the run position before starting the engine. The Genesis Series 1 can be moved a short distance on battery power without the diesel engine running. Caution: always check your air brakes before operating the locomotive on battery power. Remember, the locomotive will move without starting the diesel engine. The engine control switch on the EC panel must be in the jog position. The spotter button will now allow you to spot or move the locomotive on battery power. On the control console, one handle controls motoring and braking. An interlock requires the throttle to be in idle before changing directions. Computers monitor the operation and prevent switching if the locomotive is traveling above 3 miles per hour. The automatic and independent brake handles are next to the throttle. The head-end power control panel is located in the center of the cab console. The control area at the rear of the cab contains the locomotive's microprocessors. Cab receives information from the control cab area. X controls excitation required for various locomotive systems. AUX handles commands for the auxiliary support equipment. HEP controls the head-end power-related equipment. And IFC, the Integrated Function Control Computer, communicates with the locomotive systems and the display units in the operator's cab. Diagnostic switches are grouped together to simplify troubleshooting, maintenance, and testing. The engine control, or EC panel, is located directly behind the operator. A separate video program on the engine control panel is available. The battery saver circuit disconnects the battery 15 minutes after either engine shutdown or a loss of battery charging. The Battery Connect push button resets the timer. The compartment below the EC panel houses the battery switch. Caution: make certain the diesel engine is shut down before opening this switch. There are changes outside the cab as well. Ditch lights help crew members see at night. And along with the red and white strobe lights built into the cab's contour, help increase the locomotive's visibility at grade crossings. The communication receptacle is next to the standard MU and the fixed, removable, and on the front end, pivoting head-end power receptacles. 2 sand fills are located behind flush mount doors. The sand valves on the front corners should be open to ensure proper sanding. The windshield washer bottles are in the same compartment. The monocoque body extends from the full-width cab to the back of the locomotive. Next to the toilet is the auxiliary control compartment. An interlock cuts off power to this area when the compartment door is open, preventing the engine from loading. The message "Won't load, side door open" appears as a summary message on the computer display. Air entering the compartment is filtered through the auxiliary air filters. These filters should be changed at regular intervals. The engine start station contains the start switch, pressure gauges, and fuel sight glass. Let's go through the starting procedure. Turn the engine start switch to prime. Check the sight glass and hold the switch until the flow of fuel oil is free of air bubbles. When the fuel oil pressure reaches approximately 40 psi, turn and hold the engine start switch to the start position. It takes a few seconds for the computer to complete its circuit checks and preparation. If the engine doesn't crank, Hold the start switch in the start position for about 30 seconds. The computer will log a fault that will help to troubleshoot the problem. Valves that select the sections of the tank from which the fuel is drawn and returned are mounted against the outer walls. An instruction plate explains how these valves operate. There are other video programs in the series that explain the operation and servicing of the 7FDL diesel engine. The lube oil filter and lube oil cooler are located behind the engine. The air filter compartment houses the baggy filters. They should be changed regularly and are easily reached from either side of the locomotive. The radiator cab area houses the equipment blower and filter assembly for the number 2 truck and its traction motors. Unlike older shaft-driven air compressors, the advanced AC-driven air compressor improves fuel economy by putting no demand on the diesel engine when it's not running. Its independent AC power allows the Genesis Series 1 to charge a train with the engine operating at notch 1 or idle. Below 40 degrees Fahrenheit, the AC motor runs continuously to keep the lubricating oil warm. The control panel next to the air compressor contains the contactors that control the compressor's speed. In notch 1 or idle without head-end power, the compressor can run at twice the engine speed. The hostler station is located at the rear of the Genesis Series 1. From here, the locomotive can be operated in reverse up to 10 miles per hour. To set up for hostler station operation, you must set the air brakes in the main cab for trail operation. Insert the reverser handle into the hostler console to activate the controls. Move the hostler station's MU2A to the lead position to cut in the air. And press the brake pipe charging button to charge the brake pipe to 110 psi. To move the locomotive, you must press and hold the brake release button and one of the 3 throttle notch buttons. Release the throttle button to return the engine to idle. To apply the independent brakes, release the brake release button. The water sight glass and water fill for the wet radiator system is above the hostler station. Unlike the Dash 8, the Genesis Series 1 uses shutters to help maintain a constant engine temperature. Just past the engine is a safety door that protects us from the high voltage in the rectifier area located between the engine compartment and the operator's cab. Now let's take a look at the location of some of the components that are concealed by the Genesis Series 1's aerodynamic design. The air inlet for the dynamic braking and self-load resistors is directly behind the operator's cab. The next screens provide air for the front truck blower that cools the number 1 and number 2 traction motors and the head-end power alternator. It is also the air intake for the alternator blower that supplies cooling air to the main alternator and electronic panels. The alternator blower also pressurizes the control compartments. These screens at the rear of the locomotive provide air for the radiators, the air compressor, and the number 2 truck blower that cools the number 3 and 4 traction motors. The new lightweight fabricated trucks featuring multiple shock absorbers improve ride and adhesion. The parking brake will automatically engage when the locomotive is stopped and the air removed. It may be released manually and is automatically released when air is applied. The battery compartment is underneath the deck behind the fuel tank. The Genesis Series 1 is equipped with a specially designed fuel tank with independent fuel cells to prevent the entire contents of the tank from leaking in the event of an accident. This completes our equipment familiarization of the Genesis 1. GE has produced separate video programs that cover the operation and maintenance of the Dash 8 locomotive. Your instructor has additional material to help you review and remember the information we've covered. Please ask your instructor any questions you may have about this innovative locomotive.
Welcome to the Dash 8 Equipment Orientation Program. The purpose of this tape is to familiarize you with the new Dash 8 32BWH locomotive. The horsepower rating of this locomotive is 3,200 horsepower at 1,050 RPM. This Dash 8 is a 4-axle locomotive equipped with a head-end power option. With head-end power on, the diesel must be operated at 900 RPM to provide 60 Hertz electrical power. At 900 RPM, full power drops to 2,800 horsepower. Full head-end power, about 800 kilowatts, consumes 1,000 horsepower. This leaves us with approximately 1,800 horsepower for tractive effort and other auxiliary loads. Let's look at some equipment found on this new Dash 8. Looking at the front of the operator's cab, you will see low-profile red and white strobe lights for improved visibility at grade crossing. Ditch lights will improve nighttime visibility. A communication receptacle is mounted next to the standard MU receptacle. There are both fixed and removable HEP receptacles on this locomotive. Make sure that you latch the HEP plugs properly when inserting them. Mounted in the nose are 2 separate sand boxes. Don't forget to check both boxes when servicing sand. There are sand valves on all 4 corners of the locomotive. They should be in the open position for proper operation of the sanders. Using the latest in insulating and sound-absorbing material reduces road noise while allowing ease of maintenance. Careful design of the desktop has placed all the gauges and controls within easy reach of the operator. The single handle of master controller permits easy switching from motoring to braking. A mechanical interlock requires that you place the throttle handle in idle before changing directions. Onboard computers monitor this process and guard against accidental direction changes if speeds are above 3 miles per hour. Backlit switches and warning lights mounted on the console surface provide for easy identification and operation. Both the automatic and independent brake handles are next to the throttle. The spotter button allows movement of the locomotive using its own batteries. The engine control switch must be in the jog position for this circuit to work. Caution! Check your air brakes before using this button. Remember, the locomotive will move. An MU stop push button is in the overhead console. Check that it is in the run position before trying to start the engine. Also located in the overhead console are the controls for the head-end power system. Let's look at some other items of interest on the engine control panel. The label for the top 2 rows of circuit breakers show the items that must be on for either lead or trail operation. The Diagnostic Information Display Panel, DID, allows us to talk with the locomotive's computers. The DID panel is discussed in greater detail in the engine control panel videotape. All computer fault resets can be done by following the information on the decal next to the DID panel. Another option included in this locomotive is a battery saver circuit. A timing circuit automatically disconnects the battery 15 minutes after the engine is shut down. Resetting the timer can be accomplished by pressing the Battery Connect push button. Inside the compartment under the engine control panel, we find the battery switch. Make sure the engine is shut down before opening this switch. The control compartment in the operator's cab houses the three main computers, cab, X, and aux. These computers control operation of the locomotive using inputs from the operator and strategically placed sensors. Moving to the right, we find a switch bar that contains various diagnostic switches. A detailed explanation of these switches can be found in the locomotive service manual or in the self-test videotape. The fourth computer, called HEP, controls the head-end power circuits. Leaving the operator's cab, we find air inlet screens for the braking and self-load grid resistors. Below the air inlets is the auxiliary control compartment door. A door interlock shuts off the high voltage in this compartment when the auxiliary control compartment door opens. Note, if this door is open, the locomotive will not load. The DID panel also will display a summary message, won't load, side door open. This is not a fault and can be corrected by simply closing the auxiliary control compartment door. The auxiliary control compartment houses the circuit breakers for the HEP and air conditioning. Next, we have the auxiliary air filters. These filters provide clean air for the electronic equipment and should be changed during the 180-day inspection. The V-screen at the top of the locomotive contains plastic spin filters for the front equipment blowers. An identical inlet screen is on the opposite side of the locomotive. A three-phase AC motor drives the equipment blowers. The computers calculate required cooling air and run the blowers at 1/4, 1/2, or full speed. Blower usage is kept to a minimum, further increasing the fuel efficiency of the Dash 8. Behind this door, you will find the start switch, gauges, lay shaft lever, and fuel sight glass. When starting the Dash 8, the start switch must be turned to the prime position. Examine the fuel sight glass. Make sure that it does not contain air bubbles. When the fuel pressure reaches about 45 psi, turn the switch to the start position. Hold the switch in this position. There will be a 2 or 3 second delay before the engine begins to rotate. Circuit checks and preparation by the computer occur during this brief period. If nothing happens, continue to hold the switch in the start position for about 30 seconds. The computer will attempt to log a fault, pinpointing the problem. The fuel filter housing has a vent valve and an automatic closing drain valve. Don't forget to close the vent valve after changing the fuel filter. Next, we have the water storage tank, lube oil cooler, water pump, and water cooling system drain valve. A door on each side of the locomotive holds plastic spin filters for cleaning the engine intake air. The three-phase motor that turns the air compressor only runs when necessary. If ambient air temperature falls below 25 degrees Fahrenheit, the compressor runs continuously. This strategy will help keep the compressor oil warm and free-flowing during cold weather. A second equipment blower provides air for the rear truck traction motors. A motor-driven radiator fan cools the dry radiator system. The computer powers the fan only when it is necessary to cool the engine. Here is the oil pump, oil bypass pressure relief valve, and the oil fill. Each side of the engine has an oil fill and dipstick. The rectifiers are replaceable units that bolt to the bus bars. Fuses on the RUs do not have a blown fuse indicator. If a fuse blows, the DID panel will display a fault indicating which fuse is bad. This is the hot air discharge area for the grid resistor package. Caution, hot air is present while in braking or self-load. The control air regulator and air gauge are mounted in control area 7. The battery box for HEP-equipped locomotives mounts in front of the fuel tank. These connectors are for the wayside head-end power hookup. This area holds the switchgear for head-end power. Door interlock switches shut off HEP power when the doors are open. We hope that this brief introduction to the Dash 8 32BWH will help you locate the major components on your locomotives. Further information can be found in your GE Running Maintenance Manual, GEK 80082, other videotapes in this series, or by contacting your GE service representative.
Welcome to the future of railroad motive power, the Amtrak Genesis Series 2. Built by GE, the Genesis Series 2 represents the latest generation of modern passenger locomotives. We'll be taking a look at some features found only in the Genesis Series 2, and some of the features it has in common with the Genesis Series 1 and other GE locomotives. The Genesis Series 2's smooth lines are due in part to its monocoque construction. On the outside, the new streamlined body reduces wind resistance and improves fuel economy. The new lightweight unibody monocoque design is so strong that underneath the shell, the heavy twin I-beam sill used on freight locomotives has been eliminated. The most obvious difference between the Series 2 and its predecessor Series 1 is that the Series 2 is a dual-mode AC locomotive. 90% of the differences between these two generations of the Genesis series are related to this power difference. Details of AC locomotive theory and operations are available in a separate videotape program. The Series 2's 7FDL12 diesel engine features electronic fuel injection and delivers 3,200 horsepower for traction and head-end power. Precision computer control of head-end power frequency, power, and voltage are crucial to passenger comfort and equipment reliability. Let's go inside the cab and look at some of the exciting changes. The latest sound-absorbing insulation reduces road noise. All the controls are easily reached by the operator. The Integrated Function Display, or IFD, allows the operator to communicate with the onboard computers that monitor operator commands, locomotive systems, and diagnostics. The view-only screen on the helper's console displays information but does not accept commands. You may refer to a separate GE video training program for more information on Integrated Function Control, or IFC, operation. The MU Stop push button is to the right of the display screen. This must be in the run position before starting the engine. This locomotive does not have an engine start station. The engine startup is done from the operator's cab. After performing the normal walk-around inspections prior to starting the diesel, there are a couple of additional items that must be checked on the Genesis Series 2. Check the oil level for the air compressor. This is a visual check of the sight tube. The BFCO switch located in the CA1 compartment must be in the normal position. The reverser handle must be centered, and the engine control switch must be in the start position. Finally, especially if there has been any maintenance performed on the locomotive, all of the bolt-on covers over the inverter modules must be in place. These covers activate cutout switches which will not allow engine cranking if the covers are not in place. To start the diesel engine on the Genesis Series 2, you use the mode control switch and mode change push button. Located next to the headlight controls on the far right of the cab console, this switch and push button is also used to control the various stages of operation between diesel and third rail modes. When performing an initial start of a dead engine, the diesel can be started with the mode control switch in any position except the third rail diesel off position. After verifying the position of the mode control switch, you initiate the cranking process by pressing and holding the mode change push button. After the button has been held in for approximately 3 seconds, an audible alarm will sound and an engine start in progress message will appear. Once the alarm and message appear, the push button can be released. Once the cranking process has been initiated, it can be aborted by pushing any engine stop button. Let's examine the procedures for changing modes of operation, switching to and from third rail and diesel operations on this dual mode locomotive. Whenever you switch operational modes, the procedure is the same. You first use the mode control switch to select which mode of operation you desire, and you initiate the selected mode by using the mode change push button. When making a mode change, press and hold the mode change push button until the mode change in process message is received. When moving from diesel to third rail mode, proceed as follows. On approach to third rail territory, turn the mode control switch to the diesel shoes down position. Press and hold the mode change push button to initiate the change. Note the change under the shoe position caption on the operator function screen. Once voltage is seen under the rail volts caption on the operator function screen, turn the mode control switch to the third rail engine on position. Use the mode change push button to initiate the change. Note the change on the operator function screen, third rail and engine on. This position transitions power from diesel mode to third rail mode. Once this transition has been made, turn the mode control switch to the third rail engine off position. Use the mode change push button to initiate the change. This position shuts down the diesel engine. Note the change on the operator function screen, third rail and engine stopped. Note that on any mode change, the position of the combined power handle need not be changed to affect the transition. When moving from third rail to diesel mode, proceed as follows. Nearing the end of third rail territory, turn the mode control switch to the third rail engine on position. Use the mode change push button to initiate the change. This position starts the diesel engine. Once the engine has started, turn the mode control switch to the diesel shoes down position. Use the mode change push button to initiate the change. This position transitions power from third rail mode to diesel mode. Once 0 volts is seen under the rail volts caption on the operator function screen, turn the mode control switch to the diesel shoes up position. Use the mode change push button to initiate the change. This position is used for normal diesel mode operation. Note that the third rail shoes will not raise as long as the system senses third rail voltage. The Genesis Series 2 can also be moved short distances on battery power without the diesel engine running. Caution! Always check the air brakes before operating the locomotive on battery power. Remember, the locomotive will move without starting the diesel engine. Be sure that the engine control switch on the EC panel is in the jog position. The spotter button will now allow you to spot or move the locomotive on battery power. On the control console, one handle controls motoring and dynamic braking. An interlock requires that the throttle be in the idle position before changing directions. The automatic and independent brake handles are next to the throttle. The Series 2 locomotive is equipped with a blended braking system that features electronic control of the pneumatic and dynamic braking operations. The head-end power control panel is located in the center of the cab console. The HEP control switch is now a 3-position switch rather than a 4-position switch as found on the Series 1. The control area at the rear of the cab contains several of the locomotive's microprocessors. AC cab receives information from the control cab area. ACX controls excitation required for various locomotive systems. AC aux handles commands for the auxiliary support equipment. HEP controls the head-end power-related equipment. And IFC, the Integrated Function Control Computer, communicates with the locomotive systems and the display units in the operator's cab. Diagnostic switches are grouped together to simplify troubleshooting, maintenance, and testing. The engine control, or EC panel, is located directly behind the operator. The diagnostic display that was on the engine control panel on the Genesis Series 1 locomotive is not present on the Series 2. These diagnostic functions have been incorporated into the LDM, or Locomotive Data Monitor, as part of the Integrated Function Control located in the main console. The battery saver circuit disconnects the battery 15 minutes after the loss of battery charging. The Battery Connect push button resets the timer. The compartment below the EC panel houses the battery switch. The monocoque body extends from the full-width cab to the rear of the locomotive. Leaving the operator's cab along the A side of the locomotive, we first encounter the toilet compartment. Located for operator convenience, the toilet is both heated and ventilated. Next to the toilet is the auxiliary control compartment. A new feature on the Series 2 is this capacitor discharge indicator, or CDI panel, which is mounted on the door to the auxiliary control compartment. These indicators allow the operator to tell at a glance the status of the capacitor discharge inside the compartment. When the door to the auxiliary control compartment is opened, an interlock switch cuts out the high voltage supply to the compartment. Remember, any time that the pickup shoes are in contact with the third rail, there will be power on the feed side of the third rail circuit breaker. When the door is opened, a summary message will appear on the computer display. Air entering the compartment is filtered through the auxiliary air filters. These filters should be changed regularly. Another different feature on the Genesis Series 2 is the rotary air compressor. Located in its own compartment forward of the alternator, which is ventilated by the alternator blower, the compressor motor is driven from the HEP power source at 480 volts AC. The Genesis Series 2 is powered by a GE 7FDL 12-cylinder diesel engine. There are other video programs available that explain the operation and servicing of this engine. The Series 2 locomotive features a hot start system that works to maintain engine oil and water at 140 degrees Fahrenheit when the engine is shut down. This system reduces the diesel engine warm-up time required when operating in diesel mode. The lube oil filter and lube oil cooler are located to the rear of the engine. The air filter compartment houses the baggy filters. These should be changed regularly and are easily reached from either side of the locomotive. The water sight glass and water fill for the radiator system is above the crossover walkway. The radiator cab area houses inverters and their associated microprocessor controllers, equipment blower, the radiator tank, and the radiator fan. The hostler station is located at the rear of the Genesis Series 2. From here, the locomotive can be run in reverse at speeds up to 10 miles per hour. To set up the hostler station, you must set up the air brakes in the main cab for trail operation. Insert the reverser handle into the hostler console to activate the controls, and press the brake pipe charging button to charge the brake pipe to 110 psi. To move the locomotive, you must press and hold the brake release button and simultaneously press one of the 3 throttle notch buttons. Releasing the throttle button disengages motoring and returns the engine to idle. Releasing the brake release button applies the independent brakes. Leaving the hostler station along the B side of the locomotive, just past the engine is a safety door that protects us from the high voltage in the rectifier area. This area is also equipped with an LED display panel located to the right of the door that indicates the status of components inside. Opening this door will disable the locomotive's high voltage system. Now let's take a look at some of the components that are concealed by the aerodynamic design of this Genesis Series 2 locomotive. The air inlet for the dynamic braking and self-load resistors is directly behind the operator's cab. The next screens provide air for the front truck blower that cools the number 1 and number 2 traction motors and the primary third rail line filter reactor. It is also the air intake for the alternator blower, which supplies cooling air to the main alternator and electronic panels when operating in the diesel mode, and the air compressor. The alternator blower also pressurizes the aux cab. These screens at the rear of the locomotive provide air for the radiators, and the equipment blower that cools the inverter equipment, the secondary line filter reactor, the HEP filter reactor and capacitor, the HEP transformer, as well as traction motors 3 and 4. There are changes outside the cab as well. Crossing lights help crew members see at night when the front headlight switch is in the bright and crossing lights position, and flash on and off when the horn is sounded. This is another new feature on the Genesis Series 2. The communication receptacle is next to the standard MU or multiple unit receptacle. The HEP receptacles are fixed mounted on the rear of the locomotive and pivot mounted on the front to allow clearance for a snowplow. 2 sand fills are located behind flush mount doors, which have been moved to the sides at the front of the locomotive. The sanding valves and windshield washer bottles are located in the same compartments, situated on both front corners of the locomotive. The lightweight fabricated trucks feature multiple shock absorbers, which improve ride and adhesion. Each truck is equipped with mounting supports for third rail pickup shoes and end-of-axle ground brush assemblies. The parking brake will automatically engage whenever air is removed. It may be released manually and is automatically released when air is applied. The Genesis Series locomotives are equipped with specially designed fuel tanks, which have separate fuel compartments. This feature is designed to minimize fuel leaks in the event of an accident. The battery compartment is located underneath the deck, behind the fuel tank. Also located underneath the deck are the EMI line filters, power filters, HEP transformers, and HEP filters. This completes this program on equipment familiarization on the Genesis Series 2 locomotive. GE has produced other video programs that cover the operations and maintenance of the Genesis Series 1 and Series 2 locomotives.